Let us look at partial derivative of implicit functions. But first of all, let's be reminded of what an implicit function is. Here, we're comparing it with explicit functions. Most functions you see are explicit functions, right? Now, for explicit functions, it generally in the form y is equal to f of x, right? You have y equal, y would be the dependent variable, y equal, and there is no more y. What you have are x and numbers. X's and numbers after that. So the dependent variable is isolated, and it's much easier and more straightforward. Alright? Example, you might have y is equal to x squared. It could be y equal x squared plus 3, right? Y equals square root of x minus 1, things like those. Those are explicit functions. Now, one that is implicit. Now, the implicit function itself is generally of the form f of x, y equals 0, right? You have x and y mixed up together. You don't have them separated. It's harder to solve, right? You might have examples. X squared plus y squared equal 1. You have the x and y mixed up together. This you can transpose this to make y the subject, so you turn it into an explicit function, right? You might have a case like x squared plus 2xy plus x cubed y cubed equals 0, right? This one you wouldn't really be able to transpose like that, but that's an implicit function. You have the x and y's mixed up together. It's not necessarily equal to 0, it could be equal to some other number. Alright? So those are the explicit functions and the implicit functions, right? Now, here, let's look at the general technique for differentiating the implicit function, right? Here, you have a case where you say f of x, y is that's an implicit function equal to 0. You need to find out what is dy by dx. How do you deal with that? Well, let's say you're going to use partial derivatives to do it. Use partial differentiation. Say z is equal to a function of x and y. Now, you might remember the general formula that we looked at in earlier videos. A small change in z is equal to the partial derivative of z with respect to x times a small change in x plus the partial derivative of z with respect to y times a small change in y. So del z is equal to delta z by delta x del x plus delta z by delta y del y. The delta is partial derivative and the del is small change, right? They're all delta, but you just call them one delta and one del. The delta is a partial derivative, and then the one that is a small change we call del. Alright, let us divide by del x and see what happens here. Del z divided by del x. Alright, del 2 times del x is equal to delta z by delta x, del x divided by del x, plus delta z by delta y, del y divided by del x. Alright, so that's what we have there. But del x cancels del x. So we have del z by del x is equal to delta z by delta x plus delta z by delta y, del y by del x. Alright, good. But the thing now, if we make del x tend to 0, then we will change all the dels to delta. You remember when we looked at differentiating from first principles, right? You have a small change, del. When it tends to 0, then you call it d. So the del, you change them to d, not delta. I said delta earlier. Change it to d. Right? So what we have, when we have these small changes tend to 0, right? Then dz by dx is equal to, remember, the delta here now is not a small change, it's partial derivative. Partial of z with respect to x plus partial of z with respect to y times dy by dx. Alright. Now, here, we started out by saying f of xy is 0 and z is f of xy. So therefore z is equal to 0. Now, if z is 0, then, or we could say z is 0, this implies that the z by dx is equal to 0. So we have 0 is equal to partial of z with respect to x plus partial of z with respect to y dy by dx. And we transpose for dy by dx. So if we put this on the left, partial of z with respect to y dy by dx equals, we subtract partial of z with respect to x from both sides, so I have negative partial of z with respect to x. And remember, when I say partial, it means partial derivative, the partial derivative of, right? So dy by dx is equal to, you're going to divide by partial of z with respect to y. So it's negative partial of z with respect to x divided by partial of z with respect to y. Alright? So that's what we have there. So that's a general technique that you're going to be using to differentiate implicit functions. We'll look at those in our next set of videos.